whether it converges or diverges,
And then we have to
and
take the test we use.
state the test that you used and explain, show or explain how you got your answer. So don't just state that it converges or diverges, you'll need to show your work. And also state the test that you're using.
Hey, so how do we do that? Can we, yeah, let's start this.
Well, any
Number one.
number one? So number one,
I can do it without it, just like that. I can't state which test it is.
well, the series is 16 times 6/7 to the nth power. Well, what kind of series is that?
I don't know, dude.
What's that?
Geometric.
Yeah, it's a geometric series. Remember, a geometric series is one where you have a constant times a number to the nth power. All right? So if it's a geometric series, you're going to use the geometric series test. So how do you tell if a geometric series converges or diverges?
If R is greater than or less than 1.
Right, you see if R is greater than or less than 1. Now what's R in this problem?
6 over 7.
All right, 6/7. How does that compare with 1?
Less than.
That's less than 1. So does this series converge or diverge?
It diverges. It converges it,
Well, with the geometric series, the series converges if R is less, if absolute value of R is less than 1.
So it's less than 1.
Since it's less than 1,
It
this
converges.
series converges.
Charles right, so it converges at 6 over 7 though.
Well, no, it does. This doesn't tell you what it converges to. It just tells you that the series converges.
it's
So
R
with
is-
these convergence tests, the test doesn't tell you what the sum of the series is. It just tells you whether it converges or diverges.
And now we have to find some.
Well, not unless you're asked to
Geometric.
find the sum.
So on the test, will we be asked to find some?
There may be some problems where you're asked to, there may be 1 or 2 problems where you're asked to find the sum of a series. That would just be for a geometric series or a telescoping series.
Oh, so those are only.
Because those are the only ones for which we actually have formulas for the sum. So remember, for a geometric series,
So we don't have to say what it converges or diverges.
remember with the geometric series, so number A times R to the n. Remember that the sum of the series, if it converges, is given by A over 1 minus R.
Okay.
Just recognize that here A actually refers to the first term of the series.
Which is 16 in this case.
It's not 16 in, oh wait a minute. Yeah, if it
Okay.
starts at 0, yes, it's 16.
Okay.
Okay,
And R is 6 over 0.
yeah. So if it started at a different value of n, then to get the first term, you would have to plug in that value of n.
To n power, okay.
Yeah.
Okay.
All right.
So if like it was n equals 2, you plug in 2, solve that, and then that would be R.
That would be your A. And then R is just whatever number is to the nth power. All right. But for most series, you're not going to, the test isn't going to tell you what the sum is. It just tells you whether it converges or diverges.
Uh-huh.
All right.
And that's the formula for if it,
That's for a geometric series.
mm-hmm.
Right.
And the sum is, oh, okay.
All right. So here that refers to problems 1 through 9, where you're determining whether the series converges or diverges, stating the test that you're using and showing how you got your
Okay.
answer.
So number 2, it diverges, and you can tell it diverges because it's 1 over n. And which test?
Well, what type of series is the one in number 2?
Is it a root series? Or what's the name of the series? No, that's not what you just.
Well, what is the name of the series? You're going to need to know this.
You have to memorize all the
That's
names, or they
a
won't?
P series.
Yeah, that's a P series.
A P series.
Yeah, P series is one where you have have a constant over n to a power. So, yeah, how do we tell if a P series converges or diverges?
P is
Well,
less than.
It converges if P is what?
Greater than
Greater than 1, and diverges
it's less than
if,
or equal to
yeah, P is less than or equal to 1. So, right, since 6/7 is less than or equal to 1, that one does diverge. Yeah.
Oh, so 6, 7 is less than 1, which means it diverges.
Right.
Okay.
So, that's for
Yes.
a P series.
The next one, that's an alternating series.
All right, what's that?
Number 3.
Yeah, number 3 is an alternating series. How do you tell if an alternating series converges or diverges?
Don't you ignore the -1 bit? You can ignore that.
Yeah, so you just ignore the power of -1 and see what the limit of the terms is. So remember, for an alternating series, if the limit of the terms is 0, assuming that the terms are decreasing in size, then that would tell you the series converges.
Can we do it?
It means it converges 0.
And then if the limit is not 0, then what happens?
It diverges.
It diverges, but what would tell you that it diverges? What's the test that tells you that a series diverges if the limit is not
Is
0?
it the ratio test?
Not the ratio
Or the
test.
root test?
It's the nth term test. Remember, the nth term test tells you that if the limit of the terms of the series is not 0, the series diverges.
Oh, yeah, because you have to, don't you plug in 1 since it's like that?
So if
Can I just
So if we're looking at number 3, where the terms are -1 to the n minus 1 times 1 over the log of n, well, what is the limit as n goes to infinity of 1 over the log of n?
Zero?
Yes, 0, because log of n gets large without bound. Since the limit of the terms is 0,
Oh, and it's alternating between 1 and -1.
well, it's not alternate, well, I mean, this factor is alternating
Yeah.
between 1 and -1.
That's what makes it the alternating series.
That's what makes it alternating series, the fact that the signs alternate.
Okay.
So this power of -1 just gives you the signs. All right, so since the limit of the terms is 0, what does that tell us?
It converges to 0.
Well, not that it converges to 0, it just tells us the series converges. And it's the alternating series test that tells us that.
So every time whenever we have to write, so that one's the nth term test, right? And that's the one where you put the limit.
Well, it's not that, it's only, you're only using the nth term test if the limit is not 0. Because if the limit is not 0, then the nth term test tells you that it diverges.
So before you can figure out that it's not 0, what are you looking at to know that you need to use it?
Well, you would just take the limit of the terms, and if the limit of the terms is not 0, then the nth term test tells you the
Can
series
we do one that
diverges.
limit of the term isn't 0?
All right. Let's look at number 4, which is another alternating series. So you have -1 to the n times n plus 1 over, this is number 4. So it's times n plus 1 over 5n plus 10. So again, it's an alternating series. So you'll take the limit of the term. So take the limit as n goes to infinity of n plus 1 over 5n plus 10.
So you don't have to worry about, that's like in the one before, you don't have to worry about the -1 to the n whatever.
Well, yeah, as if it's an alternating series, you look at the limit of the terms without that factor of -1 to the n.
And so, this limit is approaching 1 over 10.
Not 1 over
Like
10.
0.
Infinity over infinity.
Well, it's in the form infinity over infinity, so what can we do? L'Hopital's rule. So what's the
But how is it
derivative?
approaching infinity over infinity?
Because n is going to infinity, so n plus 1
Is increasing.
yeah, and so is 5n
5
plus
and
10.
okay.
So, since we can use L'Hopital's rule, what's the derivative of n plus 1? Right, 1, and the derivative of 5n plus 10,
5.
right, is 5.
Oh, y'all.
So the limit is 1/5.
Mm-hmm.
So what does that tell us?
It diverges in 1/5.
Right, it diverges because that limit's not 0. And what's the test that tells us that this series diverges?
L'Hopital's rule.
No, that's not the
It'd be the
convergence
alternate
test.
series,
That's just a method for finding limits.
Would it be the end term?
Yes, the nth term test that tells us that.
But if it would have equaled 0, then it would have been the alternating series test.
That's right. So remember, the alternating series test can only tell you that a series converges. And the nth term test can only tell you that a series diverges.
Oh, okay.
Oh, we can only use.
So we
the
only have,
alternative
we're only,
zero.
for all of those, like 1 through 9 is gonna be either the alternating, either gonna be the geometric in term or the alternating series.
No, not just those, because we have a bunch of other tests as well.
Okay.
At the heading of these problems, it lists all the tests that you could possibly use.
Oh, and there's gonna be all the tests.
Yeah, so those will all be listed there. You'll just need to remember what each of these tests are and how to use them.
Okay. There's 10
But
tests.
which-
Yeah,
Each test will be on our test.
well, you'll have a list like this
Okay.
on the test.
Okay.
That might not necessarily be.
So you'll see the names of the tests, but you'll need to
Remember
remember
what they do and how
what
to
they do, how they work.
Do you know how many questions are on the test?
Probably somewhere around 12 to 15 or something like that. Probably no more than 15.
Let's finish that. A quick question.
All right.
For the alternating series, so we have on the side of the series or equation or whatever, we have an is greater than 0, and in the definition it says limit as n approaching infinity, an is equal to 0.
Right.
So for right here, so in the original problem, our an is 1 over log n, right?
Yes.
Okay, so that, do we automatically know that's greater than 0?
What?
Like, cause that, we have to know
Yeah, I
it's
mean,
greater than 0 in
the
order
log
to get
of
the limit.
the log of n is, at least for values of n larger than 1, is always positive.
Right, so that's a given, cause we had to know that's greater than 0 in order to get the limit.
Right. Well, I mean, in order for this to be an alternating series, that would have to be true.
So what we have on where that's less than 0?
Not with an alternating series. All right. Any other questions on these 1 through 9?
Those seem simple.
Can we do number 5?
Yeah.
Just because it has the end equals 2.
All right. So number 5. And let me just mention that as far as convergence or divergence goes, it doesn't really matter what your starting value of n is.
Okay, I was just gonna say that, but do we have to plug it in, or not all the time?
No, you don't have to. I mean, to see if it converges or diverges,
You have
you're
to
never
plug
going to
it.
have to plug in that starting value.
Yeah.
Well, let's see. Number 5 starts with n equals 2, and the terms are 3n minus 4
over
N squared minus
over n squared minus 3.
And this says,
All right. So what?
series is it?
Well, in this case, there's not a particular name for this series. But if you have a series like this that involves powers of n, what's the test that we would most likely want to use with this?
PC?
Well, it's not a p-series because you have those extra terms.
Is
in
it the
numerator.
telescoping test? No, it's the
It's
integral
not a
test.
telescope. Well, You could try using the integral test, but that's not gonna be the easiest way to
Direct
do this.
comparison.
I don't know how to use any of these.
Yeah, you'd wanna use one of the comparison tests, either the direct comparison test or the limit comparison test.
I knew it was a comparison test. I don't know. It just looks like.
So what would you want to compare this with? Yeah, I mean, basically either 3n over n squared or just n over n squared. And of course, what would that simplify to?
1 over n,
1 over n.
which is 1 over x,
Yeah.
which is similar to 1 over x.
Yeah, although we don't need to change it to x
Okay.
with the comparison test.
So
Alright,
which comparison test is this? This is direct
Well,
comparison test?
if we try to compare this expression with, say, 3n over n squared, do we know for sure which way the inequality goes? No, the problem is the numerator's smaller, but the denominator's also
Bigger.
smaller.
Oh, yeah, that's wrong.
So that doesn't really tell you which one is bigger or smaller. So since there's not an easy comparison between them, you would want to use the limit comparison test for that one.
Because of the numerator and denominator, because they both going small.
Normally that's.
Yeah, you would only want to use the direct comparison test if it's easy to tell whether which one is greater and which one is
It's
smaller.
smaller. Okay.
I go back and listen
And
to
it's
the
difficult
recording.
because it squared is on the bottom, and if it was on the top, we would have.
Well, it's not just that n squared is on the bottom, it's just that you're subtracting a number from the numerator and
And the-
denominator, so if you have a smaller numerator and a smaller denominator, then the
Uh-huh.
inequality could potentially go either way.
Okay.
Alright, so it'll be easier just to use the limit comparison test with this one. Okay. So, any questions on that?
Well, we like,
Can we practice
Would it?
it?
I mean, you'd have to actually carry out the test.
can we do it?
Alright, so to do the limit comparison test, what do we do? What are we gonna take the limit of?
As n approaches infinity, or 3n over n squared.
Well, just that?
No, 3n minus 4 over n squared minus 3.
So we wanna take the limit of that divided by,
The derivative,
not the derivative,
antiderivative.
not antiderivative. No derivatives or antiderivatives
divide by the
involved in this
comparison.
test. You just divide it by the series you're comparing it with.
Oh, 1 over.
So, yeah, or probably easier if we use n over n squared.
To cancel out.
Alright. So to simplify this, what's 3n minus 4 divided by n?
3 minus 4 over n.
Right, it'll be 3 minus 4 over n. And then if you divide n squared minus 3 by n squared,
1 minus 3 over n squared.
right, you're gonna get 1 minus 3 over n squared. So what do we get for the limit as n goes to infinity?
3.
Yeah, it's gonna be 3 over 1, so it's gonna be 3.
Oh, because those two just don't happen.
Alright. So what does that tell us?
Why is it 3 and 1? Oh, because those are. the-
Because the 4 over n goes to 0 and 3 over n squared goes to 0.
Anything from 1
So
over-
remember, in this case, if you get a finite and positive limit, what does that tell us?
That it either diverges or converges.
Well, according to what?
It both converges.
Yeah, the two series either both converge or both diverge. So you need to see what this series does. So does this series converge or diverge?
It diverges.
Yeah, it diverges.
I don't know, I just thought it diverges.
So of course, what does that tell us about this series?
It diverges.
Yeah, that it also diverges.
And it diverges at 3.
No, it doesn't diverge to anything.
Also,
It
we don't
just
have to
diverges.
determine, we just have to determine.
Well, I mean, if a sequence diverges, it doesn't diverge to anything.
Yeah, it only converges to something.
Yeah. But with a series, you're just saying whether it converges or diverges. All right. The limit, I mean, the only reason we take the limit is to tell us that the two series do the same thing. We just need to, in order for that to happen, we need to get a limit that's finite but also positive.
So if you were to have gotten a negative number,
Well, you're not going to get a negative limit because the terms are all positive.
yeah.
The only question is whether you get a positive number or a zero.
Okay, so
If the limit is 0, it doesn't tell you anything.
So that's where you'd have to do another test to try to figure it
Yeah,
out.
or compare with a different series. So, any other questions on these?
With 6, would you use the root test?
Yeah, with number 6, that's one where you use the root test.
And 7 is that like telescoping thing?
Yeah, 7 is a telescoping series.
So, but what test is, what series can you, can you determine the series of number 6 right now? Or no?
Well, I mean, with 6, if the terms have an expression involving n raised to the nth power, that's when you would want to use the root test.
Oh, okay.
So for number 6, you would use the root test.
And the series, what type of series is it?
It's not there isn't a name for the type of series. It's just a series for which you would use the root
So
test.
not
Not every series has a
has a
name.
name. Okay.
The only ones we actually named were the geometric series, telescoping series, and P series.
Oh, so it's only like 3 named series.
Well, and then the harmonic series is the P series where P equals 1.
Mm-hmm.
All right, any other questions on those? Let's see.
How many total questions do we have on this?
On the review.
On the review.
I think it's
I don't-
17.
I forgot.
15?
17.
17?
There's
Okay.
17. Okay. So of course the actual exam's gonna be shorter than that.
Yeah. So I guess
Yeah,
we just
can we can go to like the next thing
And come back
if we
to
have
it.
time.
Yeah, we can do that.
Yeah,
I
We
gotta
should.
see how to do
I
them.
mean, we should have time to
do everything.
look at
Yeah.
each type of problem.
So we can just go straight to number 10. That's cool.
All right. By the way, we've talked about the
Almost
first 7 here, I believe, at
Number
least a
6.
little bit.
Yeah.
Yeah, because 7
Yeah.
is a telescoping series.
Okay.
Right.
Because you're subtracting successive terms of a sequence.
So can we just say which test 8 and 9 would be?
Yeah, well, what would you do with number 8?
Number 8, wouldn't you just simplify? Well, it's not the same term, so
Wait, that would be,
the nth power term.
no, that would be
The
the
nth
limit
test.
comparison test? Or
Well, I
direct comparison
mean,
test?
You could try the nth term test. I think with that one, you would find that the limit of the terms is 0, though.
Yeah.
So the nth term test wouldn't apply.
It wouldn't.
So would it be direct or limit comparison?
Yeah, you'd want to use you'd want to use a comparison test with number 8, because if the minus 3 and plus 2 weren't there,
Yeah.
then you'd have a geometric series.
Oh, okay.
So with number 8, where the terms are 2 to the n minus 3 over 3 to the n plus 2, what would you want to compare that with?
So 2 to the n of 6.
Yeah, just compare it with 2 to the n over 3 to the n.
I was thinking it too.
And how can we write that a little more simply?
2 over 3.
Yeah, I can write it as 2/3 to the nth power. And of course, what type of series is that? If you have a constant to the nth power?
Geometry.
Yeah, that's a geometric series.
Constant to me.
So here you're comparing it with the geometric series. All right. And of course, does this geometric series converge or diverge?
It converges,
Right, it converges.
which means this one converges as well.
Well, I mean, you have to make sure the comparison, you have to make sure. You have to actually apply either the direct comparison test or the limit comparison test to be sure.
So we're doing the limit comparison test.
Well, you could use the limit comparison test.
But it'd be direct because you're adding.
Well-
right?
Can we tell how these two compare? Can we tell which way the inequality would go?
No.
Well, I mean,
Denominator.
Top one's
Oh,
smaller.
the top is
Yeah.
going.
You got a
Trying to say-
smaller numerator
And a larger.
and a larger denominator.
Right. So it's approaching like 0 to infinity.
Well, we don't need to take the limit here. We just want to see if
You
this
can tell
would
the
be less than or
difference.
greater than.
Oh, it's less than 1.
Yeah, it's, well, not less than 1. It's less, this
Than
is less than
2/3.
this.
Yes.
Okay.
Because here you have a smaller numerator, which would make it smaller, and a larger denominator, which would also make it smaller.
so you can tell the difference.
All right, so since they compare directly like this, you could try the direct comparison test. You just have to make sure that the inequality is going the right way to apply the direct
So
comparison.
what if it was
test.
opposite? How would you fix it?
Well, if it was going the opposite way, well, this one is, we actually know converges. So if the larger series converges, what would that tell us?
The smaller series can
Yeah, that the smaller series also converges.
Oh, why?
With the direct comparison test, if the larger series converges, then the smaller series also converges. And then if the smaller series diverges, then the larger series also diverges. But if this went the other way, if the smaller series converges, does that tell us anything?
No.
No, that wouldn't tell us anything. Or if the smaller series, or if the larger series diverges, would that tell us anything?
So wait. This, which, 2n minus 3 is the smaller series. That one is the smaller.
This series is smaller because it
Mhm.
has, or
Because-
these terms are smaller than these terms because you have a smaller numerator and larger denominator.
Also, if
than
it's
you have
smaller
here.
than the one it's compared to, that meaning converges. It,
Well,
One is compared
if
to
you
the
have a
others.
comparison like this, that, and
So
the
direct
larger
comparison
series
would
converges,
add
then the
numbers.
smaller series also converges. So the way the direct
See, I can put
comparison
something
test
and I'll say
works,
another big difference.
which is what we're doing here, is that if the larger series converges, then the smaller series converges.
and vice versa.
Well, not vice versa. If the smaller series diverges, then the larger series diverges. So you just have those two cases.
So if the smaller series were greater than 2/3, or 2n over 3n, would that mean that it would diverge?
If it was 2n plus 3 over 3n minus 2, it would diverge.
It would diverge.
Then it would be, well, it wouldn't diverge, it would just mean this inequality is greater than, and in that case, the direct comparison test wouldn't tell you anything.
Exactly.
So it doesn't exist like that. You were using the wrong comparison.
Yeah, you have to use the limit comparison test if that happened. So again, with the direct comparison test, if the larger series diverges, it doesn't tell you anything. Or if the smaller series converges, it doesn't tell you anything.
How do you know that the 2/3 to the nth power converges?
Because, well, it's a geometric series, and what's R?
It's less than 1.
Now, R is 2/3, and that's less than 1. With the geometric series, if the absolute value of R is less than 1, then it converges.
What test would you use for 9?
What's it for 9? All right, well, what would we use for a series that involves a factorial?
It's,
Root? No, ratio.
Yeah, that's one where we'd use the ratio test.
oh, and
So-
it's not an alternating series, or is it?
It is an alternating series, but you can still apply the ratio test. Any series that has factorials in it, or that has a constant to the nth power, that's one where you probably want to use the ratio test.
Okay, factorials and ratio.
I mean, you-
Compared it to
Yeah, I mean, with the alternating series, if you tried to do it as an alternating series, you'd have to take the limit of n factorial over 999 to the n power, which would be rather difficult. Remember when you did sequences, there was the one problem involving a factorial, and it was kind of tricky to take the limit. But the ratio test works well for that. So, any other questions on 1 through 9? All right. So in problem 10, you're asked to determine the sum of each series. All right, so, and you would only have to do that with either a geometric series or a telescoping series.
Can we practice B?
Yeah, part B, what type of series do we have in part B? Now that's a telescoping series.
That means A is G.
A is a geometric series, that's right. So for a telescoping series, so starting with n equals 1, and when you're finding the sum of a series, the starting value does matter. But the terms are e to the negative n minus e to the negative n plus 1. All right. So remember with the telescoping series, how do we tell whether it converges or diverges?
Use to find B and
Now, of course, what's the Bn in this series?
is it E to the negative?
Yeah, it's just e to the negative n. It's the sequence that you're taking differences of. So what do we do with that to see if it converges or diverges?
We start plugging one in, like the
Well,
value
you don't plug in numbers to see if it converges or diverges.
But don't you take the derivative, antiderivative?
It does not involve derivatives or
When you take the
antiderivative.
limit,
Takes
so
the
it's-
limit.
Yeah, you just take the limit of the sequence. You just take the limit of the n. So what's the limit as n goes to infinity of e to the negative n?
Isn't it negative infinity?
Well,
Well, isn't it
the
infinity?
power goes to negative infinity, but what happens to e to that power?
It decreases.
Make it
That's decreasing to what?
0.
0, right. The limit is 0. Because you can also write this as 1 over e to the n.
Yeah.
And that'll go to 0. So what does that tell us? If this limit exists,
It converges to 0?
well, it doesn't converge to 0. It
But it
just tells
converges.
us it converges. But once we know it converges, how do we find the sum of the telescoping series?
I wrote it down.
Do we have to substitute that back into the problem somehow?
Well, yeah, the sum is going to involve this limit. Remember, what you do is take the if you're subtracting in this order, the nth term minus the n plus first term, then you're gonna take the first term minus the limit of the sequence. And if it was the n plus first term minus the nth term, then it would be switched. So what's the first term of this sequence? So it'll be when n equals 1.
So e to the negative one.
Yeah, it'll be e to the negative 1 minus, and then the limit
0.
is 0. So what do you get for the sum?
E to the negative 1.
Yeah, the sum's just going to be e to the negative 1.
And they say, oh, okay, well, wouldn't that be like basically putting e to the e power, you know how e is always equals to e?
Well, that's if you're taking the derivative, right?
We're not
It's
taking
not taking
derivatives or
derivatives.
integrals here. With these convergence tests, none of them involve taking derivatives. The only one that involves taking integrals is the integral test.
And what did you say if it was the other way around, that the bn plus 1 minus the bn?
Yeah, if the order of subtraction was switched, then the order of subtraction in the sum would also be switched.
Oh, right, oh, so it's, oh, wait, I'm kind of.
So if this was e to the negative n plus 1 minus e to the negative n, so if we were subtracting in the opposite order,
Mhm.
then we'd be taking the limit of the sequence minus
Minus
b1
b1.
to get the sum.
So, the limit is equal to e to the negative n
Well-
plus 1.
Well, the limit is 0. We found that the limit of e to the negative n is 0. So this limit is 0.
Oh, so we're not even.
E to the negative 1 is the first term of the sequence.
Okay.
Any other questions on that one?
It'll be 10-8.
All right, 10A.
Sure.
All right, so that one is the series starting with n equals 3. And it's 0.3 to the n over 6. So of course, what type of series is that?
A geometry.
It's geometric.
Because it's going to the nth power.
So how do we find the sum of a geometric series?
A over 1 minus 1.
Yeah.
Yeah, it's a over 1 minus r. Now how do we get a?
The
The first term of the series. So how do we get the first term of this
Which
series?
is point.
Is it 3? Is it 0.3 to the 3?
Yeah, we have to plug in the starting value of n, which in this case is n equals 3. So it's going to be 0.3 to the third power divided by 6. Now, what does that give us?
You're gonna get 0.0045.
So 0.0045. So that's the first term of the series. And then what's r?
Um, 0.3.
It's just 0.3. It's what's being taken to the nth power. The 6 is not being taken to the nth power. All right, so the sum
Is
is a over 1 minus r, right. So you're going to have 0.0045 divided by 1 minus 0.3. And then you would just work that out to get the sum.
and that's the answer.
And that'll give you the answer, right.
Should be 0.006.
Is that 3.006?
I got just 0, 0.
I got negative 0.29.
Well, it shouldn't be negative.
Well, the bottom one's just 0.7, right? So it's 0.0.
Yeah, so it's going to be 0.0045 divided by 0.7.
So 0.00642.
Yeah, something like that.
I got 0.0064.
That's
Yeah.
it.
Okay.
So any other questions on that? So in 11 to 13, you're determining whether the series converges absolutely, converges conditionally, or diverges. And of course, these are all alternating series.
Can we work through some of these?
Yeah, we can do one.
11.
11.
Can we do the alternate because they're negative
We have negative 1 to the nth power times
Yeah.
10 to the
Makes
2
sense when you
over
think about it.
n.
Yeah.
Well, when we're working with an alternating series, how do we start out? How do we investigate an alternating series to see if it converges or diverges?
And take the limit.
Yeah, we just take the limit of the terms without the power of negative 1. So we want to take the limit as n goes to infinity of 10 to the 2 over n. So what are we going to get there as n goes to infinity?
1.
Yeah.
Yeah, because 2 over n is going to go to 0, so we're going to have 10 to the 0, which is 1. Well, if the limit of the terms is 1, what does that tell us?
That it diverges.
Yeah, of course, and why does it diverge?
Because it doesn't equal 0.
Yeah, the limit, if the limit is not 0, then right, it diverges. And of course, and what's the test that tells us that?
And
Yeah, it's the nth term test. So remember, if you take the limit of the terms and that limit is not 0, then you automatically know the series diverges.
Can we do one with the, yeah, can we just do the other two?
Well, let's do 12. So with that one, the terms are negative 1 to the n minus 1 times n to the negative 9/10. All right, so again, we can start by taking the limit as n goes to infinity of n to the negative 9/10. So what are we going to get for that limit?
Doesn't it just go to 0?
Yeah, it's going to go to 0 because, of course, you can write it as 1 over n to the 9/10. So if the limit is 0, what does that tell us?
That it converges.
Right, it tells us the series converges. So now we need to see if it converges conditionally or absolutely. So how can we tell if it converges absolutely or conditionally? Well, remember what we do is we look at the series without the factor of without the negative 1 factor. So we look at the series n to the negative 9/10 and see if that converges or diverges. All right. So of course we can write that as 1 over n to the 9/10. So does that series converge or diverge?
It's going to 0, so it converges.
Well, the limit of the terms going to 0 does not guarantee that a series converges if it's not an alternating series. So now we're just looking at the series with all positive terms. Well, what type of series is this?
P.
Yeah, it's a p series. How can we tell if a p series converges or diverges?
Is less than, more or less than 1.
Yeah, compare p with 1. So here, p is what?
9/10.
And p is 9/10. How does that compare with 1?
Less.
And it's less than 1. So what does that tell us about the p series?
Converges.
Not that it converges.
Diverges.
Yeah, for a p series, that would mean it diverges.
So less than 1 it diverges.
less than or equal to 1 means it diverges, and greater than 1 would mean it converges. So if the alternating series converges, but if making the terms positive gives us a series that diverges, then
Would it converge conditionally?
yeah, that means it converges conditionally.
So, okay. So conditionally would mean, like not conditionally would be all real numbers?
Well, no, converging absolutely would
Oh,
mean
okay,
that
okay.
if you make the terms all positive, the series still converges.
So both negative and positive would be absolutely.
Yeah, so if this series if we got a series here that converges, then it would converge absolutely.
Cool.
Alright. So any questions on that? Now, if we look at number 13, what type of series is that?
Nice and no will.
Is that geometric?
Yeah, it's a geometric series. So,
Is the constant is less than the absolute value of 1? Is that the,
yeah, so remember at the geometric series test, we look at the absolute value of r. And of course, what's r here?
not negative 9/10?
That's negative 9/10. Of course, absolute value of r
Just 9/10.
is 9/10.
That's less than 1.
That's less than 1, so does this series converge or diverge?
It converges?
Right, it converges. Now, would that change if this was positive 9/10?
Nope.
No, it would still converge if this was positive 9/10. So does this converge conditionally or absolutely?
Absolutely.
Yeah, it converges absolutely. Because it would still converge if you made the terms positive. Now, that's one thing with a geometric
Yeah.
series. If a geometric series converges, it's going to converge absolutely.
Because you just take an absolute value anyway. So
Yeah.
you're basically doing that step.
Yeah. Another thing to remember is that if you use the ratio test, and the ratio test tells you the series converges, then it also converges absolutely. So we could have also done that one using the ratio test, and that would also tell us that it converges absolutely. So any other questions on 11 through 13? All right. For 14 and 15, you're given a power series and you're asked to find the interval of convergence.
Number 14.
Which one, 15?
14.
Or 14? Okay. So number 14, we have x minus 3 to the n over n cubed times 3 to the n power. All right, so how do we find the interval of convergence for a power series?
You pick a minute.
Well, what limit? What's the test that we're using to do this?
The limit comparison test.
Use the root.
Well, you remember, to find the interval of convergence, we either use the ratio test or the root test. Which one would we want to use for this?
Ratio.
Yeah, we want to use the ratio test.
And why? Because it's going to the nth power.
Because the only time you would use the root test is if you have an expression involving n to the nth power,
Oh,
which we don't have here. All right, so how do we do the ratio test? What's the limit that we take?
X minus 3 to the nth power.
Well,
Over Oh, I don't know.
So how do we apply the ratio test?
You do n plus one.
Yeah, we do the n plus first term,
and
absolute value of the n plus first term, divided by the absolute value of the nth term.
Oh, okay.
Alright. So what's of course, since it's absolute value, the x minus 3 is going to be inside absolute value.
Okay, so I'm gonna
So what's the n plus first term?
n plus one.
So it's going to be x minus 3 to the n plus 1 over
over
N plus one to the 3
n plus 1 cubed.
times 3 to the n plus one.
So times 3 to the n plus 1. And then we divide that by the absolute value of the nth term.
Well, I ask you a question once you finish this thing.
Alright, so it's going to be absolute value of x minus 3
To the n
to the nth power over,
over n to the 3 times 3n.
right, over n to the 3 times 3n squared. Alright, so what's the question?
why is it squared? Why is it?
Or, whoops,
Oh, 3n.
3 to the n, I mean. I don't know why I put 3n squared.
Okay.
Okay.
I was trying to make sure.
Okay, so what's the question?
I'm not understanding the relation of the a to the n, well, the a times the n plus 1 and the x minus 3 absolute value.
You see they adding the 1 to the.
This means you're
value.
taking the n plus first term of the series, so you're taking this and replacing n by n plus 1.
Basically, I mean, you should just do n.
Raising the power.
So you're just basically increasing the value of n by 1.
Oh, just the regular n's. Oh, yeah, never mind. Increasing the power in.
You just put plus one
I
anywhere
see
there's an
every-
n.
What is
You're
n?
just putting n plus 1 in
In
place of
n.
n.
We
Yeah.
always find the easy
Okay,
stuff, but
it's
we get
still,
confused
yeah,
by it.
I seen that it's
Alright.
I got it.
So now we need to go ahead and divide. So what's absolute value of x minus 3 to the n plus 1 divided by absolute value of x plus or minus 3 to
Doesn't it
the
flip?
n?
Is
So
absolute
it's-
value of x minus 3
To the power of 2.
n.
Well, what's n plus 1 minus n?
Oh, minus? Or the,
Yeah,
Yeah.
remember to divide powers of the same
Oh,
base, we
powers.
subtract the powers.
It just be the one.
So it's just to the first power. So it's
Okay.
just absolute value of
Yeah,
x
it's
plus
just-
minus 3. Then we have n plus 1 to the third power divided by n to the third power.
Which is n or 1.
n.
Well, what's n plus 1 divided by n?
N plus 1 over n equals 1 over n.
Well, not just 1 over n. What's n divided by n?
N, 1 plus
Is
1 over n.
Is 1 plus 1 over n, and that's going to be to the third power.
Okay.
And then what's 3 to the n plus 1 power divided by 3 to the n?
3 to the n plus 1 over 3 to the
just 3.
Was
That's
that
just
three?
going to be 3 to the first power, so just 3. So now we need to take the limit of that as n goes to infinity.
1 to the power of 3, which is 1 times 3.
Right, so in the denominator you have 3.
And then that's just going to go to infinity.
Well, it's not going to go into infinity. If there's no n here,
Wait, why?
Oh, there
it-
is no n.
Why?
there's no n, so it's just going to remain absolute value of x minus 3. So you get absolute value of x minus 3 over 3.
So why is the denominator just 3?
Well, because 1 over n, as n goes to infinity, 1 over n
Is-
goes
is
to
0.
0.
Uh-huh.
So you have 1
One.
to the third power, which is
Oh,
1.
Oh,
So-
which is 1 times 3.
Right.
Okay.
All right, so according to the ratio test, when does this converge? Or when does the series converge?
At
At x minus
the absolute value of x minus 3 over 3.
Well,
We need to test
what
it.
does the ratio test tell us? How do we know, when we do the ratio test, how do we know that a series converges?
If it's less than one.
Yeah, if the limit is less than one.
Yeah.
So this will converge if this is less than one.
And it is.
Well,
Oh,
for
we
some
gotta
values
find-
of x, but not
not
for all
all.
values. What we're trying to find we're trying to find the values of x for which this converges.
Okay.
So what we'll do, once we've got this inequality, we'll solve the inequality.
Mhm.
All right, so how do we solve that inequality?
Can you multiply 3 or something?
Yeah, we can start by multiplying by 3
I
on
was
both
thinking- I was
sides.
thinking that too, like, do we just.
So we
So
get
we get x by itself, basically.
yeah, so absolute value of x minus 3 is less than
3.
3. Now, how do we rewrite the inequality so that it doesn't have the absolute value?
Add 3.
Well, we can't add 3 because it's inside the absolute
Yeah.
value. We first need to remove the absolute value.
ln.
No, there's not, that's not
Because
gonna
you
remove
know you
absolute
said-
value.
I don't think I'm.
Remember what we do is we write this as a compound inequality.
Oh, okay.
So what do we put on the left?
Negative.
Negative 3, and on the right,
Positive 3.
positive 3.
Oh, and that's the answer?
Well, now how do we get x by itself?
Add 3.
Now we can go ahead and add 3, and of course we'll have to do that on both sides. So what do we get?
0.
Less than x, which is less
Less
than
than
6.
x, less than 6.
Right, so it converges for values of x between 0 and 6. Now, are we actually done yet?
Probably not.
No, what else, what do we need to do to finish?
Determine the interval conversion.
Well, we've got that here, but there's still something we need to check.
It needs to be less than 3, right?
No,
I call it 0.
If x is less than 1.
No, this tells us that any
X-
value of x between, it'll converge for any value of x between 0 and 6.
Is it can't be 1?
Do we know yet whether it converges when x equals 0 and when x equals 6?
No.
No, we have to check the endpoints. We have to check convergence at the endpoints. So at 0 and 6. All right. Because the ratio, because that would be where this limit is equal to 1, and remember the ratio test doesn't tell us anything if the limit is equal to 1. So this is where we may have to use a different test. All right, so if we plug in x equals 0 into the series, what will it become? So if we put in x equals 0 here,
So it'd be x to the n power.
well, what's 0 minus 3? Negative 3. So we're going to have negative 3 to the n over n cubed times 3 to the n. Now, what will that simplify to? So what do we get if we take negative 3 to the n divided by 3 to the n?
You get negative 1,
Yeah, so you'll have negative 1 to the n,
which is an alternating series.
right, over n cubed. So right, it's an alternating series.
Mhm.
So how do we tell if this converges or diverges? So what do we do to tell if an alternating series converges or diverges?
We get rid of the n at the top because we can't we take it out.
Well, what do we do?
We do
We
the
share
comparison.
to the limit.
Remember, we take the limit of the term. So we want to take the limit as n goes to infinity of 1 over n cubed. What's that limit?
0.
Right, the limit is 0. So what does that tell us?
That
It diverges.
it converges.
Yeah, it tells us it converges.
Oh, it comes.
Remember, for
Oh,
an
'cause it's less than 0.
for an alternating series, if the limit of the terms is 0, then the series converges. So it converges when x equals 0. So now we need to check when x equals 6. So now if we put in x equals 6, what does the series become?
3.
Right, 6 minus 3 is 3, so on top we have 3 to the n.
And then
That's over
9
n,
times, yeah,
n
27,
cubed
yeah.
times 3 to the n. So what will that simplify to?
1 over n cubed.
Yeah, 1 over n cubed. So the series 1 over n cubed.
Which is 0.
Well, what type of series is that?
It's a geometric series.
It's not geometric.
Mm.
It's a p series. Remember, if it's 1 over n to a power, then it's a p series. So how do we tell if that converges?
3 is greater than 1.
Because that will have an
Right,
alternate
we
series.
look at p, which is
Times
3.
alternating.
So if p is greater than 1, does the series converge or diverge?
It diverges.
It converges.
That's when it, for a p series, that's when it converges. So the series converges when x equals 6. So it converges on this interval, but also at 0 and 6. So how would we write that inequality to include 0 and 6?
Equal.
Yeah, so it'd be 0 is less than or equal to
Which
x,
is less than or equal to 6.
less than or equal to 6. So that would be the interval of convergence. So, right, you use the ratio test to get your interval, but then you have to see if it converges at the endpoints. So you'd have to include any endpoint where the sequence converges.
Can we do 15 as well?
What's that?
Can we do 15?
All right, let's see, 15. So we have 10 to the 2n times x to the n over n factorial. So again, what are we going to use to find the interval of convergence? Yeah, again, we'll use the ratio test. Remember, the ratio test is always going to be the best test to use if there are factorials involved. All right, so again, we take the limit of the n plus first term over the nth term, taking the absolute value. So what's the n plus first term?
10 to the 2 n plus 1
All right, 10 to the 2 times n plus 1
plus times x to the n plus 1
times x to the n plus 1 over
over n plus 1 factorial.
n plus 1 factorial. Of course, it's absolute value of x here. And then we divide by
The same one as the question.
so 10 to the 2n absolute value of x to the n over n factorial.
What is the absolute value of x?
What? Because we're taking the absolute values of the terms when we do the ratio test.
Okay.
Here, x could be either positive or negative, so we have to take the absolute value of x.
To make sure it's positive.
Yeah. All right, so what's 10 to the 2 times n plus 1 divided by 10 to the 2n? Of course, it may help to multiply 2 times n plus
It'd be
1.
10 squared.
Yeah, 2 times n plus 1 is
2n plus 2.
2n plus 2. So right, if
So
we,
it's 10 squared.
so we get 10 squared, right. And then what do we get when we divide the powers of absolute value of x?
X reverse.
Just get absolute value of x. And what's n plus 1 factorial divided by n factorial?
N plus 1 factorial.
Just do 150.
And
Oh, no.
Now it's just going to be n plus 1. Remember, if you divide n plus 1 factorial by n factorial, you get n plus 1.
N plus 1 factorial.
So that's just using the property that n plus 1 factorial can be written as n plus 1 times n factorial. To get the next factorial, you just multiply by the next whole number. All right, so as n goes to infinity, what are we going to get for the limit?
So the infinity, right? We
So it gets smaller.
Yeah, so what's the limit?
Wait, so you plug it, are we plugging it into x or, no, just n?
We're taking the limit as n goes to
Yeah.
infinity.
Zero.
So we'll treat x as a constant.
It's gonna be 0, yeah.
Right, so we get a limit
Yeah,
of 0.
plug it in for X.
All right.
I get confused with that.
Wait, I'm a little confused.
Well, see, the numerator, since it doesn't involve n,
Doesn't really.
we treat it as a
Yeah.
constant. So as n
Okay.
goes to infinity, the numerator just stays as
It's
it
the
is.
same,
But the denominator is going to infinity.
uh-huh.
And so the limit is 0. You're taking a constant divided by larger and larger numbers, so it's going to go to 0.
Which means it's decreasing, right, to 0, okay.
All right, so what does this tell us?
It converges.
Well, 0 is less than 1, so right, it converges for what values of x?
Infinity, wait.
That's where we have to do the ratio.
Yeah.
Yeah, since we get this limit no matter what x is,
So it's all real numbers?
yeah, the interval of convergence is all real numbers.
Which is infinity.
So from negative infinity to infinity. All right, so in that case, we don't have to do anything
Wait, so
else.
y is negative infinity?
You got
Because it's
it.
all real numbers.
Because
no matter what value. you
So
plug.
any other questions on those?
I think I can do it. It's not too deep.
Alright.
It's just-
For number 16, you're using the power series representation for 1 over 1 minus x to find power series representations for the given functions. Is there any questions on those?
Yes, can we do A?
All right. All right, so for A, we want to find a power series representation for f of x equals 6 over 3 minus 2x. Again, given the power series representation for 1 over 1 minus x. So how do we do this?
Do you use one of them? Oh, no. I was gonna say we use McLaurin or Taylor or something like that.
What's that?
The McLaurin or Taylor, or is that separate stuff?
Yeah, we're not going to use the Taylor series form. I mean, we're not using the Taylor series formula for this. Because we want to use the fact that we have the series for this function. So can we write this function in a form? I did not mean to do that.
Could you do it as
I'm
a
not sure how to get rid of that.
What?
Okay.
Oh.
So can we rewrite this series so that it looks similar to this?
We have to square it.
Well, can we somehow change the 6 and the 3 both to 1?
Divide.
Would it be 2 over 1?
Could you separate?
Oh, yeah.
Well, we don't want to change the value of this expression.
Yeah.
Well, remember what we can do is we can factor out 6 from the numerator and 3 from the denominator. So we can factor out 6 over 3. So that will be times what?
1.
1 over,
negative 2x
well, 1
Minus.
minus,
2x.
well, not 2x, 2x over 3, so 2/3 x. Because you have to distribute. All right. So now we know the series for 1 over 1 minus x is the series with terms x to the n. So now how can we get the series for this function? Of course, you can factor out the 6 over 3, which is 2. And then what do we do with the 2/3 x?
You have to factor it out again?
Well, not factor it out. Well, see, this is the series if we just have 1 over 1 minus x. So if we have 2/3 x instead of x here, what do we do? Well, it's not really multiplying or dividing.
Would it just be
Do we just replace it with?
Yeah, we just replace x by 2/3 x. So instead of x to the n, we'll have 2/3 x to the n. So since we have 2/3 x in place of x, we just replace x by 2/3 x. So that's
Oh,
going
because
to
we
give us,
making that x to the end. I think I
because for the series for this, if we just have x here is x to the n, so if we replace this by something else, then we're going to replace x in the series with that, whatever that is.
Yeah.
And
So whatever x is, that's what you put in place of x.
Right, so whatever you have in place of x, you put that in place of
Place of
x.
x.
I'm recording it so we can.
Thank you. I seen that.
All right,
so that's your answer?
so that would be your answer.
And it's the answer.
Yeah.
And we done after this.
Well, yeah, with that one. we're done.
Okay.
Can we go ahead and do B?
All right, for B, we want to find a series for the integral between 0 and x of 1 over 1 plus t squared dt, and of course that's just equal to the inverse tangent of x. All right. Well, first of all, how would we find a series for 1 over 1 plus t squared? So how would we find a series for that using this series? Well, again, we want to write it as 1 over 1 minus something.
So we have to factor out.
And then
We have to factor and make it negative.
We wouldn't factor out anything because we've already got 1 on the top and bottom here. What we want to do is write the denominator as 1 minus something. So 1 plus t squared is 1 minus what?
Negative t squared.
Negative t squared.
Okay.
So to get the series for that, what would we do?
So it's the series, and then it's negative x squared.
Well, remember when we had 2/3 x instead of x, we just put 2/3 x in place of
To
x.
the n power.
So if we have negative t squared instead of x,
We're gonna put negative t squared
yeah, we just put that in place of x. So it's going to be negative t squared
to the
to
n
the
power.
n power.
So what do you do with the tangent on the other side?
Tangent.
Well, the inverse tangent of x is just what you get when you take the integral of this.
Oh, okay.
Okay. So this expression that we're finding the series for, that's inverse tangent of x. All right, so of course it may help to write this in a little bit different form. Because of course, since you've got a negative to the n power, that's going to be negative 1 to the n power.
So it's alternating.
And then t to the t squared to the n power is t to what power?
Wait, can you repeat what you just said?
So
Yeah,
if you
I'm
take
sorry.
t squared and then take that to the nth power,
T n or
T2n.
n plus 2.
no, you just multiply the powers in this case.
Oh, okay.
You take a number to a
Okay.
power, then to another power, you multiply the powers. So it's t to the 2n. All right, so that's the series for this expression. So now how do you get this series for the integral of that?
We take the integral of it and do the same thing.
Yeah, you just take the integral of the series. And you can do that term by term. You'd want to take the integral of negative 1 to the n t to the n dt. Now, of course, negative 1 to the n doesn't involve t, so that's a constant. So what can we do with that?
Get rid of it.
Well, not get rid of it, we can just bring it outside of the integral. So we're still going to have the factor of negative 1 to the n. But what's the integral of t to the 2n powered?
Oh, take the integral of that?
So the integral of t to the 2n.
T to the 2n over 2n.
Over 3.
Well, what's the power going to become?
2n plus 1
Yeah, t to the 2n plus 1
over 2n plus 1.
2n plus 1.
Okay, see, this one I did.
And now we're plugging in,
Integral equals add.
so now we're plugging in x and 0. So what do we get when we plug in x? In place of t?
X to the
It's
2n
gonna
plus
be
1.
x to the 2n plus 1 over 2n plus 1. And what do we get when t equals 0?
Or you just get 0.
Yeah, you just get 0.
I was thinking that too.
So this is going to be the answer.
That's a lot.
So that's actually the Maclaurin series for the inverse tangent of x. All right. So any other questions on that?
Will we have something like that on the exam?
Possibly.
What is
Anything that's on among the sample problems, you could possibly have that type of problem on the exam. All right, now number 17, you're finding the first 4 terms of the Taylor series centered at a equals negative 1 for f of x equals x to the 4 thirds. Are there any questions on that?
Can we go ahead and do it?
All right. So this is where we'll actually use the Taylor series formula.
I'm gonna bounce.
All right.
Okay.
So the function is f of x equals x to the 4 thirds. And of course, what's the Taylor series formula? Remember, you take the nth derivative of f at a over n factorial times x minus a to the n. All right, and in this case, a is negative 1. All right, so what do we do? What do we need to do? We're going to take this function x to the 4 thirds, and what are we going to do?
Plug it in.
Don't you do the integral
Not integrals.
derivative?
Yeah, we start taking derivatives.
So 4 thirds x.
All right, the first derivative is 4 thirds x to what power?
1/3.
1/3.
The 1/3 power.
The next one is 1/3 times 4 thirds, which is.
Well, that's just 4/9.
Yeah, it would be 4/9 times x to what power?
The negative 2/3.
Right, negative 2/3.
And then it goes to
Negative
18
8/27.
Yeah, it'll be negative 8/27, because 4 times negative 2 and 9 times 3.
Yeah.
X to what power?
Negative 5/3.
Right, negative 5/3. And you're asked to find the first 4 terms, so this should be enough to give us the first 4 terms. All right, so now what do we do with these?
Plug in negative 1.
Yeah, we plug in negative 1.
Wait, can we have Taylor series in? Because I like this one.
All right, so what do we get when we plug -1 into x to the 4/3?
-1.
Well, is it gonna be negative? If it's to the
-1.
4/3 power.
Yeah, it's
When we plug in
negative.
-1 into x.
Well,
Yeah.
yeah, what's -1 to the 4/3 power?
-1.
Well, how do you take a 4/3 power of a number?
Multiply by
Cube
4
root.
was 4 and then.
Cube root.
You take the cube root, remember the denominator of the power tells you what root to take. So cube root of -1 is
-1.
-1. And then what do you do?
To
Take it to the 4th power. What's -1 to the 4th power?
1.
Right, it's +1, so you actually get +1.
Wait, so why when you plug it in the calculator it gives?
Because you probably didn't put.
Did you put parentheses around 4/3?
No. Okay,
That's
let me
probably
see.
why then.
Because it's probably just doing like the power of like whatever
It's still
1
giving
point
me -1.
whatever 4 divided by 3 is.
Did you put, did you put parentheses around -1?
Okay.
Because it's the
If
same.
you take a power of a negative number, you have to put parentheses around the negative number.
1. Okay, so put a parentheses on the
Yeah.
okay.
That makes sense.
Everywhere.
Alright. So now if we plug -1 into the first derivative,
I got this, y'all. I got this.
what do we get?
4/3.
Negative
positive or
numbers.
Negative.
Yeah, it's gonna be -4/3, because here we're just taking the cube root of -1, which is -1,
Mhm.
and times
Oh, what the-
4/3.
Why is it negative?
Because -1 to the 1/3 is -1,
Mhm.
and so
Oh, I put it
4/3.
to the 4/3 instead of the 1/3.
Yeah, it's to the 1/3 this
Okay.
time.
Okay.
Alright, so
Okay.
now we're gonna plug -1 into 4/9 times x to the -2/3.
So the cube root is -1. And
Yep,
then
I got
do
that.
that to the power of -2.
But the power is a negative. Does that affect
It's just
anything?
That makes it
alternating
whatever
between
X,
negative
So
right?
and
remember, a
positive.
negative power just means you're taking the reciprocal.
So it's
Okay.
1 over x.
So it's 1 over x to the +2/3.
Oh,
It would just
that
be
doesn't
1.
help me.
It'd be
Yeah,
1
so again, you
over
get
9.
+1.
Oh.
So you get 1 over 1. Which is
So
I
just
got
4
4
9. It's
nines.
4
Yeah,
nines.
you get 4/9, +4/9.
Yeah.
And then if you plug -1 into -8/27 x to the -5/3.
Oh, hold on.
It'd be -1 and then -1.
So it's 8.
1 over -1, so it's negative, so it's 8 over 27.
Yeah, 8 over 27.
The answer is
It's
8 over 27.
Yeah, it's +8/27.
it's longer than the calculator.
It really do. It takes forever on the calculator.
Alright, so now to get the series. Okay, so for the first term, when n equals 0, that's when you're just gonna have the original function.
Yeah.
So there's gonna
Which
be
is-
1. And then of course, what's 0 factorial? That's just 1.
I knew it was
And
like
then
1.
x minus a to the 0 power is just 1. So you just get 1 for the first term. Now for the next term, well, it's negative, so we're gonna have -4/3. And of course, so that's over 1 factorial, which is,
Isn't it through 1/3?
1.
no, it's just 1.
1.
And then that's times, of course, a is -1, so what's x minus -1?
Positive A.
So it's x
plus 1.
plus 1. And since that's when n equals 1, it's just to the first power. And then the next term, so when n equals 2, so for the second derivative, we got 4/9. And that's gonna be over 2 factorial.
Yeah, and then we just add it again.
And so that's times x plus 1
squared.
squared.
I know what we're doing now. Yep, and then the next one is 4.
Well, we have
8 over 27.
Oh yeah, 8 over 27.
8/27, so that's the
Over
third
3
derivative.
factorial.
Over 3 factorial.
X plus 1 cubed.
Right, times x plus 1 cubed.
Y'all see that? Y'all see that?
Alright, so here, what are we gonna get? For
Negative
this,
4 over 3.
we're just gonna get 1 and -4/3 times x plus 1. Now, what's 4/9 divided by 2 factorial? Of course, what's 2 factorial?
It's 3.
It's not 3, it's just 2.
2.
It's 1 times 2.
But isn't it also then the 3 one is 1 times 2 times 3?
Yeah, 3 factorial is 1 times 2 times 3.
Okay.
All right, so what's 4/9 divided by 2?
You fancy y'all? Hold on, my calculator
2
tripping.
Yeah, it's just gonna be 2/9.
You know what, it's so, never else.
Because if you divide by 2, you're taking half. Half of 4/9 is 2/9.
Yeah,
And so that's times x plus 1 squared.
I'm gonna take my shine.
All right, and then we have 8/27 divided by 6.
Yeah, divided by 6.
So what's that?
Which is that?
So it's 8/27 times 1/6.
Right.
So 27 times 6.
162.
So it's 8/162, but so that's 4 divided by 2. So is it 484?
4/81.
Right, it's 4/81 times x plus 1 cubed.
Yeah.
So right, that's it.
Alright. And yay.
And that's the answer.
That's the answer.
And easy,
All
y'all.
right. Now,